So I guess we can get started. Really appreciate Lucas and Chris and David here, and also William and I will be here to help see if we can kind of take a look and spread the word or give feedback. And also Bruce is here. Later, if Jake is joining, that'll be great too. But thanks for joining. This is AllERCDevs seventh episode of season 2. Um, the the goal is to create a community for all ERC builders to become the kind of IETF where people can kind of bring their goal standards together. Yeah, we have Jake, who is the lead developer of VIEM and EVM. Well, and today the topic is ERC 7677, brought to you by Lucas Rosario. Thank you for coming over. Lucas, when he signed up, didn't know that he would be in this band, so he's effectively calling in midnight. Really appreciate the commitment. I think it's an important topic, and thank you for presenting. Oh, if you guys are close to each other, you should hang out. And also the other topic is brought to us by David and Chris, which is domain wallet authentication. Also with us are Jake, who I introduced, as well as William, who is the lead author of ERC 721 NFT, and a bunch of other standards. So I guess we can get started with ERC 7677. So Lucas, take us over. Take it over.
Sure. Let me just share my screen. Okay, can you guys see this?
Yeah.
Cool. Yeah, so I'm going to be talking about ERC 7677, which is the Paymaster Web Service capability ERC. So first, a little bit about me. I'm a software engineer at Coinbase. On the Base team, I've been working with Coinbase Wallet, the Coinbase Wallet team, for the past few months on our smart wallet, which is our 4337 wallet. And I'm a co-author of EIP 5792, which Jake presented a couple weeks ago, 7677, which I'm going to talk to you all about today, and 7682, which maybe I'll come back and talk about that one too. First, like a prereq for ERC 7677 is EIP 5792. So the history there is in February 2024 at ETH Denver, Coinbase launched its smart wallet. And there was kind of a problem where, while we were like super stoked about solving like some UX issues, specifically, you know, having like passkeys and being able to get rid of seed phrases for users onboarding, we were kind of missing something, because smart wallets can take advantage of things like batch transactions and paymasters, but there was no way for apps to communicate to wallets about those kinds of things. And the solution we decided on was to reopen EIP 5792. So we did that in March, but you know, EIP 5792 was proposed a while ago, like 2 years ago, became stagnant. But then when we realized that we were missing this kind of interface for apps to talk to wallets about you know, more advanced features that newer wallets can take advantage of, we decided to reopen 5792 with a couple of modifications. One of the important modifications specifically is this introduction of capabilities, which is this like abstraction that the wallet can use to communicate to apps about what kinds of features the wallet supports. And that communication, or like that, works the other way too, where apps can send like calls to wallets with some additional context in the form of like capabilities. So you see here, there's like this wallet get capabilities RPC, which is defined in 5792. And the response to that is like capabilities, which are like independently defined in their own ERCs. And yeah, those are like features that the wallet supports. And again, when you do like a wallet send calls, which you can think of like as like an enhanced ETH send transaction, you can include like additional context in the form of like capabilities. So after we like reopened 5792, this is where 7677 came into play. So along the same line of like the batch transaction issue, smart wallets can also use like paymasters, but apps didn't have a way to communicate to wallets like how to use a given paymaster. And the solution we landed on was standardized paymaster service RPC methods and an EIP 5792 capability for apps to give wallets a paymaster web service URL to communicate with. So important context here, like paymasters are ultimately just contracts. Like you can use them without web services. And the most common example of that is like an ERC20 paymaster. You don't need a web service to do that. You just need like the paymaster address. But most commonly, you use paymasters with some web service where the validation for whether or not a paymaster will sponsor some transaction depends on some like signature that's generated off chain by this service, which you then like pass along to this contract during the user op submission. So there's like three pieces to 7677. There's like this paymaster service interface, which the expectation is that paymaster web service providers implement these interfaces or this interface, and there's apps need to do a little bit of work, and the wallets need to do a little bit of work interface with these new methods. So if the paymaster service interface, this specifically includes two new RPC methods, PM paymaster stub data and PM paymaster data. PM get paymaster stub data returns stub or like values that are supposed to be used in paymaster fields of an user operation, and a wallet would use this during like mass estimation. It accepts an unsigned user op, an entry point address, chain ID, and like a context object. And this context object is like or not defined anyway. The idea that the context object is where master service can tell users to put things in there. One example is Pimlico, for example, has this idea of policies and like policy IDs, so apps can put like the policy ID in the context object.
Lucas,
with that policy ID.
So, Lucas, your connection degraded for us. Seems like your connection is reduced. Can you try to either refresh your browser or? Yeah. It seems, yeah. Yeah, perhaps you can turn off your camera, maybe. Yeah.
Okay, turn off camera, resharing the window. Can you see my screen? Yeah, okay, cool. Yeah, so this PM get paymaster stub data. Please interrupt me again, by the way. I don't have like another monitor or anything, so just speak up if something's going wrong. But yeah, this context object, again, is just like defined by paymaster service providers, and apps put stuff in there that paymaster service providers know what to do with. PM get paymaster data returns values that are supposed to be used in like a signed user op. So these are not dummy or like stub values, and they will be used during like the user op getting submitted to the bundler. So the request parameters look the same. and the response is like the same. It's just not stub values. So here's an example of what a request looks like. You have a user operation, an entry point address, chain ID, and some like context object. And the response just has like paymaster and data, or if you're using entry point 0.7, paymaster and paymaster data. So that's like the paymaster side of 7677. Now we'll talk about like the app implementation. So one thing the app needs to do is give wallets a paymaster service URL that they can make, that the wallets can make the aforementioned RPC calls to. And they do this using an EIP 5792 wallet send calls request. And like I said, this send calls takes like an array of calls and this capabilities object. And 7677 defines like this paymaster service capability that has this URL field. So this is like the URL field, and this is also where you would put like that context object that I was talking about. So one problem that we ran into with this design and that we wanted to address specifically in the ERC was, what if my paymaster service URL has an API key in it? That's pretty common. If you sign up for like any paymaster service provider, odds are today you'll get a URL with an API key in it. And presumably you don't want to expose that API key client side, nor do you want to like give it to wallets, because you would then have to like trust that the wallet is not going to do anything weird with your API key. So the solution we came up with there is to create a proxy that you provide to wallets as the paymaster service URL. So you, like your app would own that proxy, and then that proxy can keep API keys secret. So this is what the 7677 flow looks like before the proxy. So app would call wallet and calls. Wallet would call the 7677 paymaster RPC methods, and then submit or estimate gas with the dummy values, get the real paymaster values, and then submit to the bundler. With a proxy, it looks like this, where if your app is app.com, you would do wallet send calls, and instead of giving the paymaster service URL directly, you would give like api.app.com, which you own. And then to the wallet, it's no different. They're still just calling the standard RPC methods. But then api.app.com can keep your API key secret and just forwards the requests along to the paymaster service. And the rest of the flow is the same. Yeah, so the last piece of this is the wallet implementation, and there's two pieces there. First, wallets need to indicate to apps that they can communicate with paymaster web services via their response to a 5792 get capabilities call. So this is what a response to get capabilities should look like if the wallet supports paymaster services. It's just a paymaster service object with a single field supported set to true. And if apps see that, they know that they can pass along paymaster service URLs. And then the other piece is they need to actually like use provided paymaster service URLs and make the 7677 RPC request to the provided URL. So that's like this part of the previous diagram. And of note is like the wallet doesn't care if you're using a proxy or not. They're just going to be sending the same RPC requests just to the URL that's given. So that's the wallet piece. And finally, I'll do a short demo of this. This is just this like build on chain apps template that we worked on at Coinbase. I'm connected with my smart wallet. I'm going to click Mint NFT. And that button does a wallet send calls request with a paymaster service URL. And you'll see here, this is sponsored by Build on Chain Apps. So that's what this app is. So I don't need to pay gas for this. And I can go see this transaction.
Is there a pop-up? Because we don't see that.
Oh, sorry. Yeah. I can show this real quick. So if I click mint NFT, I get my smart wallet pop up, and you'll see that this says like sponsored by Build on Chain Apps, because this app provided the wallet with the paymaster RPC URL, and the wallet called the 7677 methods on the provided URL. So it's going to get sponsored by this app, and I can mint this NFT and not pay gas for it. And we can go see the transaction and see that I minted this smart wallet adopter NFT. So yeah, that's 7677. And finally, just a thank you to the co-authors, Dor from the Ethereum Foundation, Wilson Cusack from Coinbase, Christoph from Pimlico, and Hazim from StackUp. Thank you for everyone's time. Any questions?
Hi, thanks for sharing. I like how you've got an ecosystem here and you're looking at the different parts of it. I like how you're thinking about the paymaster, the wallet, the integration between them. I have a few questions. First, I totally don't like the proxy idea at all. It seems like an idea that's invented by Coinbase, not by the baseline assumption here is that we want to hide the API key from the wallet because we don't trust the wallet with the API key. And we want to intermediate all the transactions to our DApp-controlled infrastructure. There's a couple problems here. We trust the wallet with the keys to our signing. So I think we can trust it with the API key of where we're going to send that thing to. The API key of where we're sending things to is much less valuable than the keys to our wallet. And it's kind of an inversion of trust to instead trust our IP address and all of our other things to the paymaster, to the DApp. So I would rather have the wallet know what the API key is, which guess what? It already knows the API key is, except that right now we're using MetaMask or Coinbase or whatever hard-coded in there. And those API keys are kind of private or whatever, and magic is hiding them. But those aren't just open access, free access, 100% somebody else is paying all the bills. There's an implicit guarantee already with the API keys or service URLs that are baked into the wallets. So by using the proxy, we are now allowing the service to see the IP address of the people using it. Now, practically that might already be the case, but I think it's unnecessary to do that. And also, if you just inject URLs, you can then get the address of any Ethereum user by just having that wallet user access that URL with that IP address. Whereas today, when we use dApps, we're disintermediating because all the traffic can go through the network, which the dApp does not see. So I don't see a purpose for that. Victor also said, why use an API URL when you can use symmetric cryptography anyway? That's fine too, but I don't see the need for a proxy whatsoever. And then that was the first half. And then the second half was, I do like the idea of capability statements. You're talking to someone who worked on ERC 165, which is capabilities for smart contracts. I think it is great for extensibility, but I don't yet see why we need send calls at all. I'm still not sold on that, is because the job of the wallet is to sign things and to send messages. That's great. But it feels to me like using a paymaster and batching things or not is a fundamental capability of a wallet and an implementation detail of how you sign and message things. So you could, it's not clear to me. So like we could send a message, we could do messages and transactions, but any transactions could be bundled. It shouldn't be. I don't understand why the dApp needs to know whether the transactions are bundled or not. It feels like if you're using a wallet and there's a queue, there's already a queue implicitly there. So like you want to do a transaction, it says waiting approval 1, and then you click on something else, it says waiting approval 2. So there's a button there already, and whether you get 2 pop-ups or 1 pop-up, it feels like an implementation detail. But if there's a good reason, then I support that. But either way, whether we need send ETH calls or not, I still think capabilities is a good idea.
Yeah, I might not hit all your points. Thanks for the feedback. First thing on the on the proxy, maybe I misspoke. I think the more important piece of hiding the API key is not hiding it from the wallet, but if you are sending your your actual paymaster service URL to the wallet directly, then you're exposing it to your app's web page. So it's not that the wallet will see it; it's just that anyone who visits your app can then get that key. That is kind of the bigger concern. And the other thing is, we envision that eventually paymaster services will be able to have good enough validations such that eventually the proxy will go away. Another big piece of the proxy is that in your proxy, you might want to do validations along the lines of only sponsor ops going to this contract that are, calling these methods. But we see paymaster service providers eventually building out that functionality for the apps. And then maybe eventually you can have permissions strict enough such that if your API key is out there, then you can't really do anything useful with it, right? So that's to the proxy point. To the send calls point, so I guess one thing that's missing here is we defined another capability called atomic batch, which is just like a Boolean, can you atomically batch multiple calls? And we think this is a pretty important UX unlock. The most common use case you can think of is a token approval followed by a transfer from or whatever. And we hear from apps, and we think that it's important that we can communicate that is possible. But you're right, for EOAs, they'll need multiple pop-ups or whatever, or non-smart accounts. But we do think that there is a difference between being able to atomically batch multiple calls versus not being able to. And that has implications for the app, right? I would prefer to atomically batch a bunch of calls rather than have a bunch of pop-ups where any combination of them can fail. And that's I would rather just not deal with it and just see if whether or not the wallet can atomically batch things.
So you're saying that the dApp would choose a different thing to sign. So if it can do the atomically two things, then it would say, okay, we're going to send these two. But if the wallet says we cannot do these two things, then it's going to take a different approach, and it's not going to give you two things to sign.
It would either maybe give you one at a time, or maybe the app just doesn't want to deal with it and says, well, we're only going to support wallets that can do atomic batching.
This sounds not user empowering, and it sounds like an implementation detail still. I haven't heard the nugget yet where that you've not convinced me that the dApp needs to know that this capability exists or not, because you haven't said that we learned a thing and then we made a choice. All I'm hearing is we learned a thing we didn't need to know about, and then we are stopping people from doing something they want to do.
Okay. Yeah, I guess I see the use case where as an app, I don't want to think about the failure cases of I'm sending 5 calls, and if I send them individually, I have to wait for one to succeed before going to the next. And I'd rather not have that code path and just do the code path where I can only submit all the calls at once. That is to me, that is clearly simpler for the app that is okay with that kind of interaction.
I'd like to say atomic batch transaction actually can be a good use case to argue for this. I wonder if it makes sense to also add them to motivation. I think the current motivation section is more general and abstract, right? When you break them down into those use cases, it can make a stronger argument for people to put the design into context that you're thinking of.
Yeah, that's good feedback. And like I'd mentioned again, the atomic batching is defined in 5792 actually. So 7677 is just for the paymaster service capability, and atomic batching and capabilities in general are introduced in 5792 itself.
Cool. Thanks, Lucas. Any other feedback, questions? Jake, you hear Jake presented 5792 last time. Any words from Jake?
I don't have any questions really.
Yeah, it's your midnight, I know, as well. Any one message that Lucas want to say to the general public in terms of how you want to advocate for adoption or anything?
Yeah, I mean, thanks everyone for listening and thanks for the feedback. We're excited about this ERC. We think that there's kind of been this missing piece of, I think the big piece here is the standardized paymaster service RPC methods. There are like loose standards. For example, there's this like PM sponsor user operation RPC that people have like loosely been going with. But that also does like gas estimates, which really only work if you're using the same bundler to submit the user op. So we see this like split of get stub data and then get data is really important. And if we can align like all the players here, then I think wallets can build on top of this, which will be exciting. And then apps can build on top of it and unlock like gasless experiences for the users, which is going to be big.
That's awesome, Lucas. I happen to realize I have a question for you in terms of adoption. It seems like both app and wallets need to know, or one of them need to know and tell the other one that there exists this web service, and here's the particular URL, and if there's authentication or permission, here are how you can access them. Who do you imagine would be the first step to adopt them? Let's say, do you imagine that the app builders need to know the existence of this for them to actually access them and tell the wallet, or device would the reverse, like wallet will know them first and then include it, and then there will be a way for the app builder to query the wallet of this web?
Yeah, I think app developers need to be like looking for this kind of feature first. And we're already seeing a little bit of, there are already apps out there that support this. There are, like consumer apps on Base have been using 7677. Pimlico supports 7677, or the Coinbase Paymaster supports it. StackUp is going to be implementing it. So app developers kind of have to know to look for it. We're seeing paymaster providers kind of add support these days. I think that the more challenging piece is the wallets, right? Because there aren't that many like smart wallets out there. And I think 5792 is probably not that compelling for EOAs to implement. This kind of goes back to William's point, right? Like a big, like the best part of batching as I see it is you get rid of like multiple pop-ups. I think that's a big UX thing, but like EOAs can't do that. So there's kind of like not much incentive for them to implement this. So I think that might take a while. But then, with like EIP 7702, I think that could be a big kind of catalyst to see the rest of the wallets kind of come along and unlock this like better UX. Yeah, I think we'll get there, and we're seeing adoption in like smaller apps, and we're seeing the paymaster service providers kind of bought in already.
Alrighty, thank you, Lucas. So for developers who's watching it or watch the recording, pay attention to this new standard and make use of them, benefit your user. Alrighty, thanks, Lucas. If no other questions, I think we can shift over to the David and Chris. We have the next topic is domain wallet authentication. I think this is a very interesting one. It comes as CAIP chain agnostic improvement proposal 275. David and Chris, you can take it over.
Awesome. Hey, everybody. Victor, thank you so much for the invite. I'm David. This is Chris, and we are working on a project called Lit Protocol, which is a distributed key management and privacy compute network. Just by way of background, it is a MPC PSS, multi-party computation threshold secret scheme network that runs inside of secure hardware. And the motivation for this CAPE came through some of our work. There's a number of teams that use this distributed key for doing things like wallet as a service and programmable signing. And last year, we started to see the rise of the embedded wallet, which I'm sure you are all familiar with. These are providers like Privy and Dynamic and others. And in watching this, we were thinking about it and realizing that all of these SaaS companies were creating silos whereby people were having one key or one account per application, and started thinking about this as a real problem, especially given the underlying idea of cryptocurrency and Web3 in general, being able to have one login for the internet. And so that really got us started thinking about portability and how to make wallets portable. And what has emerged out of that is this notion of a domain wallet. And the attributes of a domain wallet, we'll get into the demo and look through the spec in just a second. But the attributes of a domain wallet is essentially taking something like a crypto domain, alice.eth, and associating it with some authenticator, whether that is a third-party authenticator like a MetaMask or Coinbase or Lit Protocol, or excuse me, like whether the key is managed by a third party or on device. The standard can call authenticators of any type, and frankly, associate an authenticator with any string with a focus on crypto domains. And just one more kind of little bit of background, and then we can look at the demo. What we see this proposal doing, and as you can see, I just made a post as an active development, just pushing out an update now, is essentially closing the loop that was started by ENS. Obviously, one of the main kind of broad benefits of ENS is being able to receive cryptocurrency at a human readable address. This completes the loop by letting folks log in to applications with their name. So go ahead and start the screen share here. We can look at a super brief demo. This is just from, I can look at the demo itself, but as you can see here, basically name gets typed in. This is using Wallet Connect to pop open this tab. The authentication happens on the wallet app, and now this is logged in. The status is connected. And with that, I will pass it over to Chris, and we can walk through some of the details of the caping and where this information is stored. And you're screen sharing, Chris.
Cool, awesome. Yeah. So Dave explained it pretty well. The basic flow is like you type in some crypto domain name, and besides just resolving the address, you resolve like the authenticator and the signer, and all that stuff. So like you said, bringing sending to crypto domains instead of just receiving. And the general idea is you type in a crypto domain name, alice.eth, whatever. And you look that up. So here's like some example code. This is pretty helpful. You look that up on ENS. ENS has the ability to store text records. And so the idea for this standard is that there's an authenticator text record. So you look up the authenticator text record for this domain name, and you get a URL. And the URL is basically the URL of where you can find the information about how to do authentication. So once you get this URL, you substitute the crypto domain into it, and you hit this URL, and you get back some JSON. And this is the authentication flows JSON that you get back. The authentication flows basically defines like, what are the different ways that you can authenticate with this service? And the idea is like to try to support lots of different devices, browser, mobile, embedded, browser extension wallets, basically.
Telegram mini apps, etc.
Yeah, Telegram mini apps. Yeah, basically anything that that could be used as an authentication standard. So this is the basic schema. So this is what you get when you look up chrisc.eth, and this tells you like, okay, here's the wallet address that's associated with this. Here's the chain where that wallet lives, which is really useful for smart wallets. If the account is an EOA, then this will be set to 0 or omitted. And then there is a array of the auth flows that are supported. We have some examples of these down here. So there's like the platform field, right? Like which platform is the user on? The connection field, how are you going to try to connect to it? And yeah, the values are not exhaustive. So as new connection types and platforms are created, the standard can be amended to include those things. And the idea is that yeah, this is great. We'll go through an example. You get some auth flows back, browser, mobile, or you could use Wallet Connect, which is platform agnostic. So the platform key is omitted. And yeah, the application will iterate through all the flows that that the authentication provider said it supports, and it will basically look for the ones that the application supports locally, right? Like if the application only supports Wallet Connect, or maybe it's a mobile app, like it'll look for a mobile one, and it finds one that matches what the platform the user is using, and the connection that it supports. Then it runs that connection, right? So if it's an extension, right, it'll use the embedded extension functionality to talk to the extension. Mobile supports mobile wallet protocol. WC is Wallet Connect. And then once I guess like the whole point of this, right, is to establish a session, right? Once the user has authenticated, then you've established a session, and then the DApp that the user is using can send signature requests over as needed via that session. And a couple little details. One is we initially said when you look up like chrisc.eth and you look up the authenticator record, that points to a URL. There's also an option where if you want to just put all of the data that would be resolved at the URL into the authenticator record, for example, like if you're on a chain that has cheap gas, or you don't want to have to run a server or don't trust a third party or whatever it is, you can just put the JSON directly into the authenticator record, which removes the need for that extra server. Yeah, we should maybe go through the flowchart. So the user comes to the app, maybe they click a button that says login with name. The application has like a little box. They put in their name, chrisc.eth. We use ENS to resolve the authenticator record, text record. It says, okay, here is the URL that you can talk to that will tell you what supported authentication flows there are. We will, I guess there's kind of like a step omitted here, which is the fact that like you could retrieve the authentication flows from a remote server, or as I said up here, if the authentication flows are directly in the ENS text record, you could just read it directly. But once you have the authentication flows, you match up the ones that you support with the ones that the authentication provider supports. And then you auth the user, and like whatever the protocol that you're using to auth them, you use that to auth them. And then at that point, they have a connection and a session that can be used to request signatures. Yeah, I don't know. Is there more stuff we should go over?
No, I think that's an overview, and I think maybe just one more note on kind of the high level here, Chris in the frame, is It's still at the beginning in terms of getting adoption here. We are like, this cape is roughly on the roadmap for many of the login modal providers, folks like RainbowKit and Wallet Connect and Privy and Dynamic and others. And what we see, and there's obviously a network effect associated with any standard, but what we see if this or something that is derivative or inspired by this can receive broad adoption, we can really move to a Web3 identity as something that can replace email as the fundamental identity online. And then one of the other cool things about this is, because this accepts any string, is that something that is a valid web URL, like alice.acme.com, could also be used as a domain wallet, as well as being Alice's homepage for a given site. So we're really, really excited about this. Kind of see it as a way to, without making any changes to the browser and without having to install any extensions, kind of using the browser bar, if you will, to squeeze Web3 into the current paradigm.
Yeah, so I guess.
Yeah.
questions?
This is so great. I really look forward to it. I think using domain as a identity reduces the friction for, let's say, identifying who is the subdomain of who, and then so you can give organizational permission to certain things. For example, if you want to open up capacities of signing certain transactions, that could be in use case.
Right. And I think it's pretty interesting there, because a lot of the authenticators, like the work we're doing at Lit or with Fireblocks or Turnkey or other folks that are doing more centralized key management, most of them all have methods for doing policies, which could also then be associated with domains and subdomains. For example, you have $1 million in an account, and somebody has like accounting.domain, and they have a policy associated on the same key and the same, without having a new wallet, but like a sub user that can, let's say, for example, only move $50 a day. Yeah, I mean, if there's no other questions, like I would say we are fully aware that Cape 275, and there is work happening in the Ethereum ecosystem. This is moving towards in the Ethereum ecosystem under EIP 7555. Greg the Greek is one of our collaborators on this. I actually had the opportunity to meet in Denver and realize we were both kind of thinking about the same thing. And he got really excited about this notion of logging in with a name and not having to see just like an endless list of wallet providers for the broadest possible way for folks to have portable accounts with digital ownership.
Any feedback?
Thanks for sharing. I like how it's similar to OpenID before OpenID Connect. And tech note, I do like that you allow inlining JSON. That is not something that makes sense to everybody at first, but after a while, they're like, oh, this is a really good idea. I know this firsthand with NFTs. You know, we snuck that in there in the beginning. And years later, people are loving on-chain only, on-chain metadata. And some websites even give you a green check mark if you use that instead of the other stuff, because it's more decentralized. And, good approach, good forward thinking. Why are we hard coding the constant WC for Wallet Connect? Is that necessary?
Yeah. It's a good question. I mean, we need to have different specifiers for different protocols. Wallet Connect is just one of it's a supported protocol, but and because it's a standard, that made sense. But yeah.
I just want to make sure that this is going to be extensible enough and that we are building in a way that is loose connections rather than tight connections. Because I want to see competitors to Wallet Connect and RainbowKit and all these things. So that was just a quick note.
Yeah, and I think there's also, just to delineate. There's Wallet Connect, the product with the UI, etc., and then there's Wallet Connect, the standard. And this cape is more about the communication protocol rather than the UI kit. And I'm sure you're aware of that, but just for clarity. Yeah, and I guess like the call to action here is please help us with this. Like if you're involved in wallets, Lucas, I've chatted with a couple of the folks at the CB.ID team at Coinbase, for example, and this is the type of thing. Our perception of this thing is that this is the type of thing that it'll be slow to start because nobody wants to dip their foot in first with something new. But once people start to kind of recognize the power of it, it'll hopefully happen very fast, and we can have a real upgrade to identity.
We'll
Lucas,
just
you
add
wanna-
email auth in there too, and then you can get faster adoption.
Yep.
Using your own first-party email server, which completely violates all the ideas here, and obviously don't standardize that, but just shove that in the back, and then fake it till you make it.
Yeah. But Lucas, you want to respond on that, or?
No, nothing specific. Yeah, I mean, I'm gonna read over the proposal, give it more time, and yeah, happy to connect you with anyone that you think can be helpful.
Alrighty. Thank you guys. Thank you, David and Chris. I hope that everyone who's seeing this try to think about how you can incorporate that into your wallet or your DApp. And as usual,
Yes.
all ERC devs is a place for people to come to get feedback, to advocate and shout for their standard. And we hope that in addition to presenting here, David and Chris and Lucas, we will also see you in the future as a reviewer, just like how Jake was helping out here. We really enjoyed your time here, and sleep tight. It's late in your time. Thanks for being here. And everyone else, thank you so much. You're welcome to present, to sign up. Next one is 2 weeks from now on a Thursday in a European and America-friendly time zone. I'll post it. But thank you very much. Yep. All righty.
Thanks.
That's
Thanks,
Bye.
Victor. You're on.